All right, so in today's video, I'm going to be talking about our sum and difference identities. We discussed our trigonometric identities the other day using our Pythagorean identities, reciprocal identities, as well as our quotient identities, and solving using those. Now we're going to build on that, and we're going to talk about our sum and difference identities. So with the sum and difference identities, what you're going to be able to do now is you're going to be able to solve for some exact values for angles that are not necessarily on your unit circle, but they are the sum or the difference of two numbers that already are on your unit circle. So like say, for example, if I asked you to find the sine of pi over 12, well, that is not on your unit circle. However, I could do that by doing pi over 4 minus pi over 6. That would go ahead and get me pi over 12. So things like that. Likewise, I could also do pi over 4 plus pi over 6, and that would get me 5 pi over 12. So just doing things like that, those are the kinds of things that we can do using our sum and difference identities. So if we're going to go ahead and discuss how, when we're looking at the numbers on our unit circle, think about the top half of your unit circle. Let me go ahead and put those values right here. So if you have these numbers right here, what you're going to now be able to do is you're going to be able to find the exact values for things using these numbers. To save yourself a little bit of headache, we're going to modify these a little bit as we go through, and I'm going to kind of discuss that with you. So right here, what I'm going to do is I'm going to find the exact value of sine 7 pi over 12. Now, I can take that sine 7 pi over 12 and put it in my calculator, and I get back square root 6 plus square root 2 divided by 4. This calculator, the TI-30XS, will give that to me. If I use a TI-84, it gives me a decimal. But right here, it gives me the exact value, and I can see that right here. Now, that doesn't help me when it says that I need to do this without using a calculator. So let's do this without using a calculator. What I'm supposed to do is I have to come up with two things that are on my unit circle that I can either add together to equal 7 pi over 12 or subtract one from the other to equal 7 pi over 12. So what I'm talking about here is I'm adding and subtracting fractions to equal another. So I'm trying to find two fractions that I can add or subtract together that's going to equal 7 pi over 12 out of the values that I have already. So let's kind of look at what we've got here. If I have the values on my unit circle, I'm going to go ahead and make my life a little bit easier and make all of these have a denominator of 12. The reason I'm doing that is because all I'm going to do is be able to figure out by taking my numerator and adding and subtracting my numerator to go ahead and equal the one that I need. So if I go ahead and look at each one of these, I put all of them as over 12. Now, the numerator over here for pi over 6, I had to multiply 6 by 2 to get 12, so I'm going to multiply my numerator by 2, and I'm going to get 2 pi over 12. Likewise here, I multiplied my 4 by 3, so I'm going to get 3 pi over 12, and so on and so forth as I go down throughout this. So this is going to be what I end up with as I go through. And so now I just kind of have to look at these numbers in my numerator and go, which one of these can add up to 7 pi or subtract one from the other to equal 7 pi? So say, for example, I could do 10 pi minus 3 pi. I could also do 3 pi plus 4 pi or 8 pi. Oh, nope, can't do 8 pi. But I could do 9 pi minus 2 pi. So I've got a couple different options that I can do there. So it's just kind of a matter of what you see to get your value there. So let's go ahead and try and figure this out. So if I do 7 pi over 12, I assume that the majority of you are going to go, oh, that's 3 plus 4. So we're going to do it as such. So I'm going to say that this is the equivalent to doing sine 3 pi over 4. Oops, not 3 pi over 4. Goodness gracious. That's the equivalent to doing 3 pi over 12 plus 4 pi over 12. Okay? And then we have 3 pi over 12 is the same thing as us going ahead and doing pi over 4. And then 4 pi over 12 is exactly the same thing as pi over 3. So I'm taking pi over 4 and pi over 3, I'm adding them together, and that's what I'm going to get. So now I have this information here. What in the world do I do with it? So that's where these equations come into play, okay? So if you notice right here, on this very first equation, I'm given sine u plus or minus v. So basically what I'm going to be doing is I'm going to be taking the first value that I have here, and I'm going to be replacing it here and here. And then I'm going to be taking the second value that I have, and I'm going to be replacing it here and here. And then I'll be able to find their exact values. Now, what's this weird little thing in the middle here? Well, this is just saying that if I'm adding these two angles together, that's the one that's on the top. So I'm also going to do the thing that's on the top over here, which is adding. Likewise, if I was, for example, to subtract u minus v, then I would be doing the one on the bottom, which means I'm going to be doing the one on the bottom here. And that works for each one of these equations. As I go through, whatever you're doing in the parentheses here, whether it's the top or the bottom, it's going to correspond to the top or the bottom over here, including over here for cosine. If I have cosine plus something over here, I'm going to end up doing minus. If I'm doing cosine minus some value, I'm going to come over here and doing cosine plus, okay? So it does switch for cosine. If I look at my tangent ones, those I'm going to go a little bit more in detail with in just a little bit, but either way, you can see here on the top I have plus minus and then minus plus, and then same thing here, plus minus. Minus plus over here, okay? So just keep in mind that those are going to be the values that you're going to be using, or the equations that you're going to be using. You're just dropping your values in there, okay? So if I refer back to that, my sine equation goes sine u cosine v plus cosine u sine v. Okay, so this is my u, this is my v. So all I'm going to do is just drop that information into my equation as it's written here. Okay, so sine u, so I would do sine of pi over 4 times the cosine of v, which is pi over 3, plus the cosine of u, which is pi over 4, times the sine of v, which is pi over 3. And now I'm going to take each one of these values and I'm going to replace them with the exact values that I have on my unit circle. So what is sine at pi over 4? Well, it's square root 2 over 2. And then cosine at pi over 3 is going to be 1/2. And then I'm going to add to that, I'm going to do cosine pi over 4. So at cosine pi over 4, I'm at square root 2 over 2. And at pi over 3, my sine is square root 3 over 2. And then I'm just going to go ahead and simplify this as I know how to do all of my basic arithmetic here of I'm multiplying a fraction together, so that just means that my numerators go together and then my denominators go together. And same thing here, multiplying straight across. So I get square root 2 divided by 4 plus square root 2 times square root 3. Remember, my square root rules say that I can go ahead and multiply those together, and it just smooshes together to become one thing. So that's going to be square root 6 over 2 times 2, which is 4. My last and final step, well, these have a common denominator, and it's just two fractions, so I'm going to add them together. So this is going to be square root 2 plus square root 6, all divided by 4. And that right there is exactly what we had on the calculator earlier when we found our exact value, and that's what we have here. Now, just remember my rule that I have that I always use to keep myself kind of remembering some of the basics sometimes is treat your square roots like you do a variable, okay? So for example, what I mean is I can do x times y becomes xy, right? But I cannot do x plus y and make it change into anything else. So like, for example, if it's like 2x plus 3y, it's just going to stay 2x plus 3y. But if I have 2x times 3y, well, then that just becomes 6xy. I can combine those. So that's kind of what I do for myself to remember what I can add and not add together, because it's a very common mistake for people to add square root 2 to square root 6 and turn it into square root 8. And I cannot do that, okay? All right, so let's go ahead and let's try a different problem over here. So here I've got tangent 11 pi over 12. Tangent is a little bit different, well, not a little bit, it's a lot bit different from sine and cosine. If I look at these equations that I've got over here, I've got two ways that I can do tangent. I can do it as just the equation of sine divided by cosine, because we should know that tangent is sine divided by cosine. So this is just your sine u plus or minus b right here on the top, and the denominator is the cosine u plus or minus b. That's what we get. The alternative is this formula right here, where I just do the tangent of my first angle plus or minus the tangent of my second angle, all divided by 1 minus plus tangent of the first times tangent of the second. I'm going to go ahead and show you how to use this equation and what we're going to do here. So when I go through and do this right here, I've got to figure out, just like I did on the last one, what two things can I add together to get tangent 11 pi over 12. So when I come up here and look at these same values that I had earlier, I've got all of these, and I still have the same denominator of 12. So that's going to make things a little bit easier for me. And so now I can look at my numerators and say, what two things can I add together or subtract one from the other to equal 11? And so that's going to be something like 9 plus 2, or I can do 8 plus 3. And that's pretty much all I can do on these values right here. I could have gone beyond pi and done values there and subtracted, but I'm just going to go ahead and just stay with where I'm at right now. Now, what I'm also going to encourage you to think about when you're doing tangents, so let's look really quick. If I do tangent pi over 6, and then I have the tangent of pi over 3. What is my tangent at pi over 6? At pi over 6, it's going to be square root 3 over 3, and my tangent at pi over 3 is going to be square root 3. So let's look and see what we can do with these values and kind of place them in the equation so you can kind of see what I'm talking about here. So if I do 11 pi over 12, as I already said, I can go ahead and make that be 9 plus 2 or 8 plus 3. So if I do 9 plus 2, that's going to be having my, let's rewrite this here. I think I'll do it both ways. So I'll do 9 pi over 12 plus 2 pi over 12, right? And then once I've done that, then I also could do tangent of, and we've got the other one, which would be 8 pi over 12 plus 3 pi over 12. Okay, so once I've taken this information and set it up, now I can go ahead and reduce it down to what they are and what I know for those values. So we know that 9 pi over 12, that is going to go ahead and that's going to be equivalent to 3 pi over 4. And 2 pi over 12 is pi over 6. And then if I do this one over here, 8 pi over 12 is equivalent to 2 pi over 3. And 3 pi over 12 is going to be pi over 4. Okay, so I've got those two options here, and so now what I'm going to do is I'm going to go ahead and put them into my equation that I've got right here for tangent. I'm not going to use the sine over cosine one. If I'm completely honest, a lot of times that makes it be really ugly. It's just kind of helpful to see that sometimes, because in a pinch, if you can't remember on an exam or something how to get the tangent equation, that's what you can do in a pinch. But I don't recommend it. It definitely gets ugly, and it gets ugly fast. So let's go ahead and let's just do it this way. So I'm going to set it up in the equation that we're given for tangent. And so that means that I've got the tangent of 3 pi over 4 plus the tangent of pi over 6. And that's going to be divided by 1 minus the tangent of 3 pi over 4 times the tangent of pi over 6. And if I come over here and did this one would be tangent 2 pi over 3, plus the tangent of pi over 4 divided by 1 minus the tangent of 2 pi over 3 times the tangent of pi over 4. Okay, I'm just doing these side by side so that we can kind of see that we're doing the exact same thing, but I just have two different angles, and you're going to see why I would choose one over the other in just a second. You might have already seen it, but let's go ahead and just investigate that side by side here. So 3 pi over 4, my tangent there is just -1. Now over here, tangent pi over 6, that's going to be square root 3 over 3. And then in the denominator, I'm going to have 1 minus, and then it's going to be -1 times my square root 3 over 3. Okay. Over here on this one, I've got tangent 2 pi over 3. Well, at 2 pi over 3, my tangent's just going to be negative square root 3. And over here, my tangent at pi over 4 is going to be plus 1 divided by 1 minus, and tangent 2 pi over 3 is negative square root 3. And tangent at pi over 4 is just 1. Now, which one of these looks easier to deal with? The one that's got a fraction up top added to a integer, so I'm going to have to get a common denominator in order to add them. And then I have another fraction on the bottom that I'm also going to have to go through the same process of getting a common denominator to add. And then I have a fraction divided by a fraction, and I have to keep change flip. Or if I just do this over here. I am going to strongly encourage you, avoid anything with pi over 6. So pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. You want to avoid those. You want to do all the ones with the pi over 3s. Do whatever you can to avoid the pi over 6s. So I'm just going to continue over here on the right and show you how to do it this way. Oh, I guess I need to scroll over here. All right, so here's what we've got. So with this equation right here, I'm just going to carry on with where I stopped right here. So my numerator is just -3 plus 1, negative square root 3, plus 1 divided by, and then I'm just going to simplify what I've got down here in the denominator. Negative square root 3 times 1 is just negative square root 3, right? And then so now I have 1 minus negative square root 3. That just becomes 1 plus square root 3. Okay, so now I've got this, but the problem that I have here is that in my denominator I have a square root, and I can't have square roots in my denominator, so I've got to rationalize this. In order to get rid of that square root in the denominator, I've got to rationalize it by multiplying by what's called the conjugate of that denominator. So I'm going to be multiplying by 1 minus square root 3 divided by 1 minus square root 3. Now, if you think back to when we were factoring and all of that, doing all of those, this is similar to changing this into a difference of 2 squares in the denominator. In fact, that's kind of exactly what it is. Simply because if I FOIL this out, the square root 3 is going to cancel out in the denominator, and it's going to bring it up top. So let's go ahead and let's do that. So if I go ahead and take the numerator and FOIL it, so let's do that. That means that I'm going to do -3, I don't know why I just drew it like that. I'm going to do -3 times 1, so that's going to get me negative square root 3. And then I'm going to go ahead and do negative square root 3 times negative square root 3, so that's going to get me positive 3. And then I'm going to do 1 times 1, so that gets me plus 1. And then I'm also going to do 1 times negative square root 3, so that gets me minus square root 3. So that's my entire numerator. And now I'm going to go ahead and get my denominator. I'm going to change this so I have a little line there. Okay. And then so to do my denominator, I'm going to do 1 times 1. That gets me 1. And then I'm going to do 1 times negative square root 3. That gets me negative square root 3. And then square root 3 times 1 gets me plus square root 3. And then square root 3 times negative square root 3 gets me negative 3. So you can see right here exactly what I was talking about. This negative square root 3 plus square root 3, it cancels out. And the reason we've done that is because we changed this into basically, like I said, a difference of 2 squares. So those are now gone. And so what I now have here is in my numerator, I just have negative square root 3 minus square root 3. Like I said earlier, treat it like a variable. It doesn't become negative square root 6 or anything like that. It's negative 2 root 3. It's just as if you had negative x minus x. That becomes negative 2x. So this is negative 2 root 3. And then I have 3 plus 1, so that becomes plus 4. And then I'm going to go ahead and divide here. And that gets me 1 minus 3. And 1 minus 3 is negative 2. I'm almost done. The last thing I can do is I can go ahead and reduce. If you notice, I've got one term right here, and I've got another term right here. I can divide both terms by negative 2. So if I do that, negative 2 root 3 divided by negative 2 becomes just square root 3. And then 4 divided by negative 2 becomes negative 2. So there is my final answer, square root 3 minus 2. You could also write that as negative 2 plus square root 3, however you write that. I'm going to go ahead and I'm going to show you how to do this problem over here, just in case you got stuck and you ended up doing one as a pi over 6. I'm going to go ahead and do it, but like I said, I don't recommend doing it this way. So from here, what I would do is I would go ahead and simplify that numerator. So I have negative 1. And like I said, I'm going to have to get a common denominator. So I'm going to turn this into negative 3 over 3. That's equivalent to negative 1, right? Plus the square root of 3 over 3. And then my denominator here, I have 1 minus, and then it's negative 1 times that square root 3. So really this is 1 plus square root 3 over 3. You see how that becomes plus because it's a negative times a negative right here. So then I'm going to go ahead and put that in my denominator, but instead of using the 1, just like the numerator, I'm going to turn that into 3 over 3 plus square root 3 over 3. You can already see how much more challenging doing it this way is and why I strongly encourage you not to do it this way. But I'm going to go ahead and take care of my numerator here. I'm going to go ahead and add them together. So that's going to get me negative 3 plus the square root of 3, all divided by 3. And then I'm going to go ahead and write divided by, and I'm going to write it over here as 3 plus square root of 3 divided by 3. And so then I'm going to keep change flip. So it gets me negative 3 plus the square root of 3 divided by 3 times, and I'm going to flip these two and do 3 over 3 plus the square root of 3. And you can see right here, these 3's will cancel right on out. And now I will be left with negative 3 plus the square root of 3 divided by 3 plus the square root of 3. Okay, and that's real similar to what I got up here, isn't it? Except over here I had 1 instead of 3. Okay, well, I mean, no big deal. So what I'm going to do is I'm going to go ahead and take this value here, and I would multiply the numerator and denominator by what? What would be the conjugate here? Pause and think for a second. It would be 3 minus square root 3. So that's what I'm going to multiply top and bottom by, is 3 minus square root 3. Now, when I go ahead and do that, I'm going to distribute that out. And what does that get me with? Well, let's look. So if I go ahead and do that, I'm going to get negative 3 times 3, so that gets me negative 9. And then I'm going to have negative 3 times negative root 3, so that's going to get me plus 3 root 3. And then I'm going to have that square root 3 times 3, so that gets me plus 3 root 3. And then I'm going to have square root 3 times negative square root 3, and that's going to get me negative 3. Once again, go ahead, draw my denominator. I don't know why that's such a thick one. Let me go ahead and change that. There. All right, and then we're going to do the same process here on the denominator. So 3 times 3 is 9. And then I'm going to do 3 times negative root 3, so that gets me negative 3 root 3. And then square root 3 times 3 gets me plus 3 root 3. And you can see how those cancel out right there. And then I have square root 3 times negative square root 3. And that's going to get me negative 3. Okay, so I can see right here, like I said, these two are going to cancel out. They go away because they are exactly the same, just different signs. And then I'm going to combine like terms up top. So I've got negative 3 and I've got minus 3. So negative 3 minus 3 is just negative 12. And then I got 3 root 3 plus 3 root 3. Well, what is that going to be? Like I said, treat it like an x. So if I have 3x plus 3x, what does that become? It becomes 6x. So this is plus 6 square root 3. And then I'm going to divide my denominator here. So now I have 9 minus 3, and that gets me 6. So I can go ahead and reduce. I can see that I have a negative 12 divided by 6, and I have a 6 square root 3 divided by 6. Once I reduce that, that gets me a negative 2 plus square root 3. So that's what I've got here. And if you notice, that's exactly what I had here, just written in a different order. So those are the same, okay? So it's just which way did you do? Which way is going to be easier than the other? And that's why I say avoid the ones that have a pi over 6, because it's really going to just make things way more challenging than you want them to be. Let's zoom out and look at both of them combined together. So if I see all of this over here, I can see just doing it without having the pi over 3. It's all of that work right there. Whereas the other one was just this part over here, okay? All of that part. So definitely be careful when doing sum and differences, and I'll go ahead and do the rest of the problems in another video.